The James Webb Space Telescope, often referred to as JWST, represents the pinnacle of human achievement in astronomy and engineering. It's not just a tool, it's a cosmic time machine, peering back billions of years into the early universe, observing the formation of the first galaxies, the birth of stars, and now, potentially, evidence that we are not alone in this vast, mysterious cosmos. Recent signals captured by JWST have sparked global excitement. Among the ancient light of distant stars and nebulas, it may have detected something artificial. Something that doesn't fit within the natural patterns of space. Could this be the glimmering trace of technology? Could it be the whisper of intelligence from a far-off world? For centuries we've asked, are we alone? It's one of the most powerful and enduring questions humanity has ever faced. Ancient civilizations looked to the heavens and imagined celestial gods or beings from the stars. Today, we look through sophisticated instruments and wonder whether those beings might be more than myth. Whether they might be civilizations, perhaps even advanced ones, existing on distant exoplanets. With the capabilities of the James Webb Space Telescope, we may be closer to an answer than ever before in history. Let's step back for a moment and consider what it means to detect artificial light in the universe. It's a concept so bold, so extraordinary, that until recently, it would have been dismissed as science fiction. But in 2021, a team of respected astrophysicists published a study exploring this very idea. They proposed that telescopes like JWST could detect the light generated by extraterrestrial civilizations, not in the form of laser beacons or radio transmissions, but as city lights, massive networks of artificial illumination on distant planets. Their main subject of interest was Proxima B, an Earth-like planet orbiting Proxima Centauri, our closest neighboring star system just 4.2 light-years away. That's astronomically close. This proximity, combined with Proxima B's position in its star's habitable zone, where temperatures could support liquid water, makes it one of the most compelling candidates for hosting life. Now, here's where it gets fascinating. Proxima B is tidally locked. That means one side of the planet always faces its star, basking in eternal daylight, while the other side is plunged into perpetual night. This strange dynamic creates a uniquely alien environment, half a world scorched by endless sun, the other half frozen in darkness. But what if, on that dark side, intelligent life evolved? What if a civilization arose there, one that learned to harness energy from the day side and beam it across to illuminate the night? The researchers theorized that an advanced species might deploy gigantic photovoltaic arrays, essentially massive solar panel systems, to collect stellar energy. That energy could then be used to power vast cities on the dark side, emitting light that, under very specific circumstances, might be visible to our most sensitive telescopes. This is where the James Webb Space Telescope comes in. JWST is designed to observe the universe in infrared light, a spectrum perfect for studying cool, dim stars like red dwarfs, which includes Proxima Centauri. In fact, over 85% of Proxima Centauri's energy is emitted in the infrared spectrum. That makes it virtually invisible to the human eye, but to JWST, it's radiant, glowing with the signatures of heat and energy that could hint at planetary activity. But how do we distinguish artificial light from natural light? This is one of the most complex and thrilling challenges in modern astronomy. Natural light sources, stars, planets reflecting starlight, volcanic eruptions, auroras, follow predictable physical patterns. Artificial light, on the other hand, might display irregularities, consistent brightness unrelated to the planet's position, spectral patterns that don't align with naturally occurring elements, or light signatures concentrated in certain regions of the planet, like clustered urban zones. Imagine a distant observer looking at Earth from light years away. Our cities would glow softly, our satellites might reflect light at regular intervals, and our radio waves would leak into space. It's this same idea, technosignatures, that we're beginning to search for beyond our solar system. And the fact that JWST may have detected something fitting that profile, even tentatively, is astonishing. Let's dig deeper into the nature of Proxima B. It's approximately 1.17 times the mass of Earth and completes an orbit around its host star every 11.2 Earth days. That's incredibly fast, but understandable, given how close it orbits to Proxima Centauri, just 7.5 million kilometers away. For comparison, Mercury is 58 million kilometers from the Sun. Despite the intense proximity, the star is much cooler and dimmer than our own Sun, meaning that Proxima B could still be temperate, especially along the terminator line, the border between night and day, where conditions might allow for stable climates and, potentially, life. Life on such a planet would be nothing like life on Earth. If it exists, it has adapted to extremes: eternal light or eternal darkness. Evolution might favor photosynthetic organisms on the lit side and bioluminescent or technologically reliant species on the dark side. Survival would depend on innovation, on finding ways to share resources between the hemispheres. Civilization, if it emerged, would likely be fundamentally shaped by the challenge of this duality. So what would alien technology look like from across the galaxy? We're not looking for sci-fi starships or radio towers. We're looking for subtle energy leaks, thermodynamic anomalies, and reflective surfaces that rotate or move in ways that can't be explained by geology or atmosphere alone. A reflective dome, a power station, or even a network of orbital satellites could all show up as faint, unusual blips in the data. Here's the most stunning part. JWST is sensitive enough to detect temperature differences of just a few degrees across entire planetary surfaces. That means if a planet's dark side has a warmer than expected region that aligns with patterns of artificial lighting or industry, it would stand out. If Proxima B's night side were emitting consistent infrared radiation that matched the profile of powered cities, it could be a telltale sign of technological life. As of early 2025, over 5,600 exoplanets have been confirmed, and many more await discovery. A large percentage of these orbit red dwarfs like Proxima Centauri. These stars, while dim, live trillions of years, offering unimaginably long windows for life to emerge and evolve. However, they also frequently flare, bombarding nearby planets with radiation. This paradox, long life versus high volatility, could either sterilize planets or drive life to adapt in extreme, protective ways. Some scientists believe that life near red dwarfs would likely be subsurface, living beneath thick ice or rock layers, shielded from radiation. In such a scenario, artificial lighting becomes even more essential, not just for survival, but for agriculture, infrastructure, and navigation. Could JWST have glimpsed the glow of such a hidden civilization? Of course, skepticism is essential. Science thrives on doubt and rigorous verification. Any signal must be thoroughly vetted, compared against natural phenomena, and peer-reviewed before extraordinary claims can be made. But still, this moment, this data, this possibility, it fuels the imagination. It reminds us that exploration isn't just about finding answers. It's about expanding the realm of what we know to be possible. As the JWST continues its mission, astronomers around the globe are fine-tuning their search strategies. They're analyzing planets that are tidally locked, planets with high atmospheric opacity, and planets that display energy imbalances. They're using spectroscopy to search for industrial pollutants, things like chlorofluorocarbons, which don't occur naturally. They're refining techniques to detect narrow-band optical emissions, the kind associated with LED lights or concentrated light sources. All of this points toward a singular goal: to determine whether we are alone in this galaxy, or whether others, perhaps vastly more advanced, are out there, illuminating the darkness. Here at Waves Discovery, we're committed to following this journey, bringing you the latest in scientific breakthroughs, cosmic mysteries, and the evolving story of human curiosity. The James Webb Space Telescope might not just change astronomy. It might change our entire understanding of life, of consciousness, of our place in the universe. So stay with us as we continue to follow the light, natural or artificial, that reaches us from across the cosmos. Be sure to subscribe, like, and click the notification bell, because with every new signal, every strange anomaly, we move closer to the most profound revelation of all. Until next time, stay curious, stay inspired, and keep reaching for the stars. This is Discovery at 2.0.